Okay, cool. So what's the problem we're solving here? It's really hard to be consistent across the company if you don't sort of lay a lot of groundwork, and you don't really want a ton of boilerplate in each individual project, or the projects take a long time. So there's two problems we're solving there, right? Like if you're fine with tons of boilerplate, then you can just use templates for everything, and that's fine. And if you're, but the templates still need to be like accessible and easy to use. Okay. So the default setup, as I said, a lot of manual maintenance as well when you upgrade a package. If you're using setup.py and requirements.txt, you got to update both of them, or the setup.py doesn't kind of work out right. So you got all those kind of problems. It's very important to have the right version of Python installed on your local machine so that you don't have to coordinate with someone over Slack over the course of 15 minutes to figure out why you can't get the app to run or do whatever. So there's all that kind of stuff. But there's also security updates and all that sort of thing. And like default, I think a Mac comes still with like 2.7 or 2.8 Python, 2.7 Python, right? Which is not super fun if you're trying to work in 3.10. So there's all those kind of problems. There's a lot of libraries that you need to manage, and you want to make sure that the versions are exactly the same. In some situations, you want to be able to upgrade quickly between the different versions of the libraries. And you also want to know that, like, I built the thing with this version, that's what's going to go to production so it doesn't blow up. And then there's also multi-architecture problem, which has a new light on it, given that x86 and now ARM64 are very popular, and we have a whole bunch of people at Spectrum with the M1 and now M2 laptops, and then you've also got people with x86 because we got people who like Linux, and then of course our production environment is still x86. Well, I shouldn't say of course anymore. Our production environment is still x86, but we're actually kind of working on that. So that's a really fun problem to solve as well. And then finally, there are a lot of build tools, but you also want like linting. We use Black for formatting primarily. There's a bunch of different testing ones. PyTest is the current winner for us. There's a lot of mocking frameworks. We use PyMock, but there's all kinds of different tools like that you want to get integrated so you know that your project's consistent. I can pick up a different Python project, and it's not a total nightmare for me. Unless I worked on it, because I always program different than everyone else, and they hate it. But like from it passed all the same sniff test. So this is all stuff that you guys must have run into before. So what is our solution? So we're doing a combination of poetry, which you guys might have heard of. Sorry, the color is kind of awful. We're doing a combination of poetry, which conforms to one of the newer Python standards. I did not write down which PEP it is, but poetry is pretty great. Uses the PyProject TOML, which can be shared across a bunch of other tools in Python, which means I can configure things like if you go, is there a laser pointer? Is there? Oh, there is. Oh, great. Well, that's hard to do. All right. You can see like I can configure Black here. Black doesn't let you configure that much because it's super opinionated. But it integrates directly in with the PyProject TOML, and I can set the line length because I'm not willing to do 80 characters. It's too short. So you can do all that. You can manage your dependencies in here. And the other thing you can do, which is really nice, is you can set the Python version. Don't ask me why I needed greater than 3.10 and less than 3.12. That's a weird problem. But we can do that. And some other things that we do here, you can see I'm using dynamic versioning. So the version's set to 000. Usually there's a comment that says don't change this. And you can kind of figure that out from the git tag. So we're using a combination of poetry, Circle CI right now, with a custom orb that's specific to Python. I'll show you, I'll walk you through a little bit of that. And it lets you do things like build and test my Python package and just run that command and give me some context, which is sort of where you hold secrets in Circle CI. So you can imagine it's like a bunch of environment variables with like, connect to, we use Cloudsmith, which is sort of like, like Artifactory. It's sort of like Artifactory, competes with that. So you can configure all of that sort of stuff in the orb, and our Python builds in each individual project are fairly small. And then we've also got some tools to let us, and here this is an example. Scram is one of our internal tools that we use for some of the build steps. So we just bake that into the Docker image that we're going to build on with the orb if you use the default image. But also we can deploy that in a bunch of different ways, which I'll show you real quick, that I think is kind of fun. So we deploy it with Homebrew, so a non-technical user can install that. I don't know why you would need to install that if you're non-technical. Go ahead. So I'm only using it within a single project. I would imagine you could. It's the same version of poetry across your entire machine. I haven't seen like a virtual poetry before, but it does handle like upgrades fairly well. Like the compatibility layer is pretty good. So I think we started off on 0x, and then we were on 1.1 and 1.2, and now we're on 1.4, and the upgrade was fairly painless. A couple of patch versions were kind of weird when running them on. We were building on a Mac machine before in order to get the homebrew build. I'll talk about that in a moment. But yeah, I kind of answered your question. Yeah, okay. So simple usage across each project. This is basically these two blobs here. I redacted some stuff because you don't need to know about it. But those two blobs are basically what happens in your project, and you get all these multi-builds. So you can get like a library build, you can get a binary, you can get a Docker image. All this sort of stuff is what we're going for here, right?
And sorry, and you have a simple flag there for dev versus prod versus whatever, or how do you manage it across? If you want different things when you develop versus.
Oh, you mean project? Oh, yeah. So they do have dev. They have a dev dependency separate concept. I actually cover that later. One of the core problems that you probably have run into if you're still using requirements.txt or something like that as a solution is that you have to also have a dev requirements.txt. And as far as maybe Peter knows, but I'm not aware of some standard that says this is what the name of that file is going to be. I've also seen requirements.pip and like other goofy stuff like just requirements, which is super confusing and kind of annoying. So I really like that it snaps to a standard. You can also do the semver is standard in how it matches and all that sort of stuff. So yeah, I think that answers. I think that's what you're getting at. Okay, cool. So what did we build? So there's a few things here. I just like pointing at it. It's kind of fun. So we have a Python template. This is a repo that's basically a skeleton and has an example.py, buried inside of the source folder. You can do source folder in Poetry, which is really nice. And then we have a separate orb, which is kind of like an extension of Circle CI, and it lets us follow various patterns inside of that. And I'll show you some of those patterns. So that runs inside of Circle. And then I'm using PyInstaller right now, and I'll tell you what problem it solves. Most people will probably hate me for using PyInstaller, or maybe you just don't know what it is. But PyInstaller lets you build basically take your entire project and create like a virtual directory in one file, which you can then start up. The only downside to it is it kind of starts up slow. But like I said, I'm targeting non-technical users, and I want to make the build easy as opposed to super performant. I have a couple things that I do a little bit more performant, and in those cases, you can package it with Homebrew, but then you need to like do extra legwork to call out which dependencies are used inside of the brew file. I forget what it's called right now. But it's kind of like the brew file specification. I'm trying not to go show you guys around my code. I was told not to do that. So we use PyInstaller to create a binary for CLI apps and whatnot. That's pretty nice for, like I was mentioning before, we had that project called Scram. We have a few others that are similar to that. One of them we call Bodak, lets us invoke gRPC endpoints dynamically from your laptop if you want to. You have to have the right permissions and things like that. So those package up as that. And then we push it to Homebrew. I have not fully automated the pushing to Homebrew. You have to still copy-paste some stuff from Cloudsmith. But it's pretty good. I think the folks in the back can tell you whether or not it's working. And then you can also push the Docker Hub. I'm actually working on this actively for Python, but we're doing it sort of a little bit of legwork there, but that will be done soon. And then we use Cloudsmith for storing of those. We'll use a raw image for the binary, and then we actually package up for Debian, and we have packaged up for CentOS and whatnot, which is a RPM, but we don't do that right now because we don't have any customers or any reason to do that.
So PyInstaller into
Yeah.
PyInstaller into Brew or?
So PyInstaller, actually, you're right. Homebrew should be, Cloudsmith should be in the middle. My bad. So PyInstaller goes into Homebrew via Cloudsmith. So I put a raw image into Cloudsmith, and then you have to annotate in a Homebrew internal repo. You annotate like which file you have. Or okay. what the checksum is in Cloudsmith, and then the name of the file.
So, I mean, let's separate just to understand read versus write.
Yeah.
If I want to install, I just do brew.
Yeah. So you do one time you do a Homebrew custom install of the GitHub repo.
Yep.
And I can send you instructions for that if you're interested. But you do that once, and you say like, hey, add this GitHub repo, which could be private, which is the thing I was going for. And then from there on, whenever someone updates that GitHub repo, they update main. And when you do git pull, or when you do brew update, it will update all of those things. And if you do upgrade, it'll upgrade all those things. And you can say upgrade individual thing.
And I use PyInstaller for the write. So when I update something, I use that to push. Is that true?
No, it's an intermediate step. So, sorry, this diagram is more confusing than it should be.
That's okay.
What is that? Anyway,
So if I develop, I mean, maybe this is a dumb question, but if I develop and I need a new dependency, what's the flow?
Sure. So if you want to add a new dependency, you add it to your, do I have that? Okay. Let's go back here. So you add the dependency here.
In your poetry, yep.
In your poetry, in your PyProject TOML.
Yep.
You add that in your poetry. You use it in your source directory, however you're going to use it.
Yep.
Right? Integrate it with your CLI. In our case, we use Click, and then we also have a fork of the Crux standard lib, which was another CLI approach. You add that, and then you push your code, right? Get a code review. It will do the build and test here already, based on this configuration. I don't retest on main in this particular case because that seems kind of like wasted effort. And then the way that we're doing it is when you tag, that will invoke a separate flow, which I might have an example of later. But that will invoke a separate flow, which then builds. If it's a binary project, and you can configure, I'll show you a couple of the commands that we have. I have a list following. It will invoke one of those commands based on your CircleCI config that's available in that Python orb, right? And I'll show you that again. So it takes that command from there, which is wrapped up in a job. There's two concepts in CircleCI. There's a command, which is sort of like set the Python version for me, and then a job is like do these 15 different commands, right? So you push that up. Once you've tagged, it'll build a binary and push it to Cloudsmith. And then it's also going to it'll push a raw file, which is the binary, which PyInstaller creates. And what PyInstaller does is it creates a virtual directory with a sort of, with an initialization. So it's like your whole Python project in kind of a zip ball that can be invoked. Is basically, you've probably done some directory stuff in a package before. So it'll do that, and then you can say like, hey, run, for example, in this project Scram, I have a main, which is just in the init.py, and the main method, you know, if project, if name equals main, it will just call that, right? And it's all in a single file, so you can move it around in your directory system. And the reason I'm doing that right now is because of, well, primarily because of that. So every now and then you run into a situation where you need to move it or something like that. Did that answer your question?
Yeah, so, and at the end of that whole process, so I just gonna work locally.
Yeah.
If I wanna bake another dependency or upgrade some dependency, I almost need to, I wanna-
You do have to file pull requests, is the way we have our stuff set up.
Yeah, but then if I wanna now see that my code is running on the latest environment, then I need to get the whole pull request approved, merge, build, then download the latest, and then I can test it on the new.
Oh, sorry, I'm talking about a CLI app that you would install on your laptop. So these are like utilities.
Yep.
If we're talking about an app, we have a separate flow for that, which is actually managed through a separate project. And ours is basically just a promotion script that will update the version. So we use semantic versions for basically everything. So if you're on 1x and you want to go to 1.1 or whatever because you had a new feature, in that case, we'll usually do an approve. Right now, we're just migrating over, but you do we'll do an auto install for some projects now, and we're going to move to this for most things. We'll do an auto install on dev, and then you approve moving to staging, and then you approve moving to production. We actually use a .version file in the projects because we talked to people about it, and that's what they wanted. I did not work on that, so you can talk to Aaron on my platform team or someone else if you really want to know why. But we're using that, and that's based on git tag. So whatever's in the repo will be, Terraform will push that. But that's based on Docker images that are in Docker Hub. So, does that make sense? Okay, was that helpful? All right, that diagram sucks, I'm sorry. Okay, cool. So what else do we do? So we use Poetry, as I mentioned before. Something that I've liked about Poetry so far is fairly easy to install, although it does involve curl, so that might turn some people's stomachs. There are other ways to install it, though. One of the things that I'm going to do soon is package it up and put it inside of the Cloudsmith repo such that you can install Poetry from Homebrew via our Homebrew, right? And then kind of keep moving, and then we can get everyone on the same version there. This is kind of weird, a little bit recursive problem, but this is just how this stuff works. So that's what Poetry kind of looks like in the command line. It's pretty great. If you want to add a new project, you just say Poetry add. If you want to remove a project, Poetry remove. And then if you want to add a plugin, you do Poetry self add, and then that plugin. For the most part, the plugins that we use, you don't need to install them locally. So that makes it really easy for us because basically you can write all this stuff. In our case, it's nice if you have the plugin installed locally because then you can do the things that you're going to do with the plugin. But for example, for bumping versions and whatnot, you probably don't need to do that on your local machine. However, the one plugin that I'm calling out here, which you can reproduce for whatever it's really nice if I could point. You can reproduce this pretty quickly for yourself. These slides are available. But if you want to do use some other tool, I'm familiar with Invoke, which is a branch from the Fabric project, which was used to do, it's sort of like a SSH but Python tool. If you guys have used PSSH, it's kind of like that. This is like the sub bit that just runs shell commands. So what am I doing? I'm basically calling invoke, but the thing that I had to finagle was getting it to call it with the right Python because you want the Python from the project you're currently in so that it will then run like PyTest or something like that, right? And then this is just how you register a plugin in Poetry. So we'll install this automatically in the CI because I put Poetry inside of the Docker image, which we'll talk about in a moment. But even on your local machine, you can install this very simple because we package it up as a library using this stack because all of this stuff has to use itself. So we package this up as a library, and you can just install it directly on your machine using the Poetry self-add. And you'll now have Poetry invoke as a command that's available. And it'll let you do things like this, like Poetry invoke build binary. And you can see the at task build binary, and then it just calls PyInstaller, right, and sets the log level and whatever. One of the next, and I'll talk about next steps later, but one of the next steps is going to be to convert that over into a library that you can just import in your task.py. But that's what it looks like. And then locally, I've called it build binary, and I can run the scram command, the help from it, on my local machine, and it's a single executable. I can move it wherever I want on my machine. It's pretty handy. So, does that kind of make sense? I hope so. Okay, cool. Okay, and then the next step, as I mentioned before, is custom images. So these are the things that we're going to build on in CircleCI. And the gist of it is we're extending a C image, which is a convenience image from CircleCI. If you're not using CircleCI, that bit's probably not super relevant. But if you are, you should probably be using the C image one. Before there was like a circle images, and those are all deprecated. And what this looks like is basically I extend theirs up above with the Python build and install that Scram project, which makes sure that your Git tags are not all screwed up. So if you add, we had a problem a while back ago where someone did 2.2.0 was on a commit below 2.1.0, which causes all kinds of weird, confusing stuff when you go and deploy 2.2.0, but it's actually older than 2.1.0. So this prevents you from doing that. It also prevents you from accidentally tagging it wrong with semantically incorrect stuff. So that's what Scram does. We also install PyEnv in case you want to switch, and then Poetry, but we also, you can locally cache different versions of Poetry, which is really nice. So you don't have to wait for it to download if you're going to switch between 1.3 and 1.4. Hopefully, does that kind of make sense? Okay, cool. And then separately, I have a Python runtime. And the way that I'm doing that is I expose the credentials to the application when you're installing, and I just do an install of the tarball. So some of this stuff, this is whip, but I install the tarball on the runtime machine, the runtime image, based on the build from the build image, and that's how you get a pretty nice, pretty lightweight Docker image. And I know I'm glossing over a lot of stuff because there's not that much time. It's 45 minutes. Does it kind of the flow make sense though? Okay, good. Okay, great, cool. So I'm hoping we'll see if there's questions. Okay, so what does the orb look like, right? So we have, this is what a standard CircleCI orb looks like. So you check out the code. You're going to do validate tag. That's the step that wraps scram, which I showed you a moment ago. Cache restore. We've spent some time making sure that the caching is pretty smart so that the Python jobs can be reasonably fast. We'll set the poetry version to whatever you want, so that's parameterized elsewhere. I'm not going to show you the whole file because it gets to be kind of a lot of YAML inside of the orb. We'll set the Python version if you want to change Python versions, which is pretty helpful because we have projects on 3.11 and we have some projects on 3.9 and whatnot still. Expose credentials, install Python stuff, install the plugins, store the cache so you can build faster next time. And then one of the commands that we added, which you can see up there, is invoke. And like I said, so the gist of it is in the project you have a task.py. Inside of that file you have those, like I showed a moment ago. You can add any task you want there, and then you can call it from the CI like this, right? And if you standardize on those, you can actually kind of get a really nice Python, pipeline for Python projects where they're all kind of basically the same internally, and you know what's going to happen, right? So like, oh, I'm going to build a binary, I'm going to build a Docker image, whatnot, right? So we do that, we do the build, and then push the thing to Cloudsmith and store the artifact locally so you can download it if you want to try it out. Here's some of the commands that we have. You'll notice this is on the alpha, and I'm on a different branch for the stuff that I'm working on for Docker, so that it's admitted. And then here's some of the jobs we have, which would be build and test. This is like general CI flow. Build a Debian, build a macOS image for Homebrew, build a library, and then push binaries. I'll probably have a couple more around Docker fairly soon on this alpha branch. And then one other thing I wanted to point out, if you are using Circle, they have custom executors, and you can name those. It just kind of bottles up like which Docker image you're going to use and like use the right credentials and whatnot. And then you can set different environment variables on your executor. So you can think of the executor as like, it's basically the in most cases, the Docker image that you're going to run on. So hopefully that kind of makes sense. But in our case, it's going to be that Python build Docker image, which has some other stuff baked into it. So I'll know like what's available. And one pattern I've found in Circle CI in particular, if you're using that, is you can parameterize the executor such that you can change it for like a bigger one or whatever later on, which is really nice. Okay, cool. So yeah, so I had, it puts me out, I wish a timer, that would be nice. Okay. Okay, cool. Significant improvements with minimal boilerplate was kind of where we got to, I think. So we use GitHub templates, like I mentioned a moment ago. That really gets you off the ground fast if you're going to do a lot of different repos. We're more of the, we're not quite microservices. We're more like macro services, but that still wind up with a lot of services, and then we have a lot of libraries. Macro is kind of like you're doing SOA still, but not, everything's not like one function, right? So we're using GitHub templates for that. The boilerplate looks pretty good. Still some challenges around like, we have to go manually configure the permissions with groups and whatnot in the GitHub repo, but it's pretty good. And you get off the ground pretty fast with the build is all set up for you. For the most part, you can get a project up and running with this workflow in about 10 minutes, which is not bad if you're forking the template. Download it, edit some code, and you can be building a binary and shipping it to someone else's laptop, usually in about an hour, not including like time to write the code, maybe less. Like total cycle time, not effort. So that's pretty cool. We have a fairly robust number of CLI apps, which is fun. We're using Circle CI orbs, like we mentioned before. If you're using GitHub Actions, there's probably something that kind of does that. Or what I would recommend, if that doesn't work, is you could probably just build more Python apps that do the things for you, and then run them through this washing machine one more time. We have poetry and plugins. The plugins thing, just the invoke plugin was really nice for us because you basically can create ad hoc build steps. And I'm a big fan of makefiles, which nobody else likes. So I use those to build various projects because I want to move between Scala and Python and Ruby or whatever quickly, and JavaScript projects, that sort of stuff. So other people hate that. What did I hit? Okay, I'm going to just click. No? All right, I give up. This thing. Nope, that doesn't work either. There we go. I can't even click. Interesting. Nope. Yes. Nope. And it crashed or something. That's weird. Yeah, it's not responding. That seems like it's fixed. Okay, so PyInstaller, pretty nice. The only thing I would say is, so that project I mentioned before for invoking gRPC endpoints, Buff is one of the tools that I'm looking at now to switch over to. They're looking at creating a thing kind of like that. But it's inspired by, there's gRPC curl, which maybe you guys have used. And there's a couple others that are kind of similar. The gist of the thing that we're doing with that is it's similar except for all of the endpoints are baked in, so you can list what endpoints are available, and you can get shortcuts and all that sort of stuff, which is kind of nice. Maybe I'll do a talk on that at some point. But we're using PyInstaller for that, and you do have to register dynamic dependencies. So, okay, you're just stretching your shoulder. Homebrew, the Homebrew repo was a lot easier to do than I thought it was going to be. I could show you guys that real quick in some code. And then the Docker build and runtime images, I think separating those is really good. So we do this in Scala land as well. It saves us a lot of concern around what's going to go on. And then we have the necessary Monty Python character. So I'll go ahead and show you. Oh, yeah. Oh, is it responding? Yeah. Sure. So if you want to do Docker, if you want to do a pure Docker image build, then just build it in CentOS and you're kind of good. And that one's going to be for the most part, like I said before, I'm using commands. So let me go back. How do let's see. Oh, the clicker's dead. Oh, it's just stuck because I hit escape or whatever. It doesn't. The gist is though, all you have to do is. Oh, can I share my phone? No, that won't work. But all you have to do is create a repo that starts with Homebrew. So ours is called Homebrew Internal Tools. I would show this to you, but I need a reboot or something. It won't work. So that's okay, because it's private repo. It's fine. So you just have to have Homebrew Internal Tools, and then I could reboot, but maybe it'll uncrash. No, it's really annoying. Oh well. Oh, maybe it's just Chrome. It might just be Chrome. I'll just reboot. Yeah. I think it's okay. Okay, so all you have to do is do Homebrew Internal Tools, and you can do a pretty lightweight definition for the Homebrew artifact, and all it's doing is pulling that repo and then syncing that up. So if you've used Homebrew for a little while, it's kind of just a Git repo with a bunch of definitions in it. So all you need to do is set the SHA-256 of the package, and then update the semver, and you get updates. I don't think I can share my screen. That's frustrating. Sorry, it won't reboot even. Yeah. So, cool. All right. Is there any questions? Is this? Yeah. Sure. Yeah.
Do you want to touch a little bit on how you mentioned you guys use Jupyter notebooks as well for a lot of experimentation?
Yeah.
How does it all come together? I mean, do you extract? So do you write the independent Python and then pull it into the Jupyter notebook? Do you pull the code out of Jupyter notebook into?
Right now, right now what we're doing is we'll publish the library separately to Cloudsmith, but you could use Artifactory just as easy. And then we're installing that in the Docker image when you build it. That's the current process. Okay. It'd be cool to have it a little more dynamic, but then I'm just rebooting it. So.
Sorry, so I mean, this is if I run Jupyter notebook locally.
Right.
Do you use
No, we deploy the image of the Jupyter notebook, the base image.
Got it.
And that's got the libraries baked into it. That's what we're currently doing. Yeah.
So,
yeah. Oh, yeah. Cool.
If I, from a workflow perspective, if I experiment, if I run some experimentation, I want to upgrade a dependency, I have to go
Yes.
to the dance.
Yeah. That's where it's currently at. I think we could, yeah. to get this up and running. Can I look at, see if this goes. Oh, that was it, shoot, okay. How do I get it to share? Oh, okay. Can I do that? Oh, I can. Okay, that's a little weird, but I'll just show you guys what the internal tools looks like. So this is our homebrew internal tools. So all you need to do is formula. Sorry, I wasn't able to pull it up. But all you need to do is update a formula file, and this is just a Git repo. All it has is this, and I'll show you a simple formula. So we just have a few projects in here, and you just create like one simple Ruby script, and then that's the thing that you're going to install with homebrew, right? So all you have to do, and I'll show you how to do it real quick. I'll show you the Scram one because it's pretty innocuous. So the gist is all you have to do is say Scram extends formula, include virtualenv, right? And then here's where the package is on Cloudsmith. I'll change that key. And then here's the SHA-256. Those are scoped to the individual repos. It's not really that big of a deal. And I don't inject the credentials separately because it's a lot of work. And then you just have to say like what it depends on, which is just Python basically. And then this is what it looks like unrolled. If you do the PyInstall, you don't have to do this bit. So right now, this one's pretty lightweight, and I want it to be really fast because I'm using it in CI. So I sort of unroll it in here instead of doing the PyInstaller thing. And that will do like click. That's gitdb. Now that's a little bit more work to update. But the thing is that it's then going to run it like as a Python script. So it'll be really fast when I'm running it in a CI job. So this one's a little bit of an anomaly. In terms of that, I will have to rotate that key. That's annoying. And then here's kind of what the gist of adding this to your project is you basically just have to do this brew tap, right? And then tap internal tools, and assuming you're using SSH for Git, you can just do that. This won't work for you, obviously, because this is our repo and you don't have permission, or some of you do. But that's it. And now I can put a Python written binary on someone else's laptop, like that's a non-technical user essentially. So that's one of the objectives. Obviously, you guys know all the modalities you can use Docker to deploy, and then libraries are you want to be able to install them. Adding libraries to Poetry is fairly straightforward, and adding a new repo to Poetry fairly straightforward. The credentials and whatnot are just environment variables. So. Cool. All right. So that's how we do that. Yeah. Okay. I'll leave the rest for questions. Was that too detailed and also boring, or was it fun? Yeah. Okay.
Yeah. In the Docker file, are you using CentOS as the base image?
No, we're using it's Debian right now, but we also use CentOS for some other stuff.
Okay. And the brew installation that was there, that was separate from the Docker file, right?
So the runtime Docker image is based on the Python runtime Docker image, and then the Python build image is the one that we'll do the build in. And the thing that you can do with that is basically install a bunch of stuff for build that you don't need at runtime. So you can manage that separately. One of the things that's really important for us is in that the Python runtime is great for most apps, but in a lot of cases you're going to want to build a Docker image that extends, like has a bunch of C libraries installed in it already for like TensorFlow or whatever. So if you're going to do runtime, you need a C library installed already. It's nice to just grab one of their base images and then extend it with a little bit of your stuff. So you just do build, and then you can do a build image and then do a new do the final image in Docker. Does that make sense?
Yeah.
Okay.
Yeah.
Cool. Yeah. So we're doing that. I think the other thing that's nice about that is then you can, at build time, from the CI, we can grab all kinds of different credentials to go download crap from Cloudsmith and whatever. And you don't want those in your runtime environment. So, yeah. Cool. All right. Was this, okay, cool. Hopefully this was helpful. Any other questions? No? Good? Everyone's going to be able to do this tomorrow? Good. Good, good. All right. Awesome. Yeah. All right, thank you.